Hello everyone, it's Miss Thomas and we are going to look at conditional probability. So this is the notation of conditional probability. The probability, and it said the probability of B given that A has occurred. So conditional probability requires some thinking when you're asked to find it. You can calculate it from a table and looking at smaller subsets, from tree diagrams, or using a formula. You only want to use the formula really as a last resort if the other methods are not available to you. And so the formula is the probability of B given A is equal to the probability of A and B divided by the probability of A. So the probability of B given A is really the probability of both occurring divided by the probability that A has occurred. Okay, so figuring out conditional probability from a table, we might want to look at a table like this, where we have a question where it's what is the probability that a sample of non-recycled waste is paper. So this is a conditional probability. Here where they're telling us what's the probability that a sample of non-recycled waste, they are limiting what we're looking at to things that are not recycled. So that's like the probability that it's paper given that it's non-recycled. Okay, so we don't want to use the formula in this situation when we have a table. What we want to do is figure out, okay, well, what's the total amount of not recycled waste? So if we add up this column, there's 136.7 tons of non-recycled waste. So probability that it's paper given that it's not recycled is just going to be equal to the amount of paper over the amount of non-recycled. So sometimes conditional probability really just limits what you're taking the percentage out of. So the amount of paper is 37.8. The amount of non-recycled waste is 136.7. So that is 0.277, which is 27.7%. So sometimes we want to do it from a tree diagram, and I'll show you how to construct a tree diagram. But 17% of all respondents to a survey are male. Of the male respondents, 33% are right-handed. Of female respondents, 90% are right-handed. So tree diagrams, basically, you have these decisions. So the first break is if it's male or female. So 17% are male, which means that 0.83%, not percent, but 0.83 are female, because these two things need to add up to 1. Then, from the male, of male respondents, 33% are right-handed. And left is going to be 0.67. And for females, 90% of females are right-handed, which means that 10% are left-handed. So this is our decision tree. So we might get asked questions like, what's the probability of being left-handed given that you're female? Well, from the tree, we just have to find where we are on the tree. And that is this portion right here. this is the probability of being left-handed given that you're female. So a tree is a lot easier to find some conditional probabilities because you're really just reading it off. Now, we might also have the probability that you are male and left-handed. So this is talking about the bigger survey respondents, right? So this is going to go back to our formula where we know if it's an and probability, we're going to do the probability of male times the probability of being left-handed given you're male. So the probability of being male is 17%, and the probability of being left-handed given you're male is 0.67%. So the probability you are male and left-handed out of all of the survey respondents is 0.1139, which is just 11.39%. So then we want to look at a situation where we might want to use the formula. So again, as a reminder from before, the probability of B given A is the probability of A and B over A. So this is just the same as the formula we just used. Probability of A and B is equal to the probability of A times the probability of B given A. It's just rearranging it. Oops. It's just rearranging it by multiplying both sides by the probability of A and moving that over here, right? So we're just moving things around. These are the same. So using our problem from before, our tree from before, you might also see the question, well, what's the probability of being female given you are left-handed? And that is going to be equal to the probability of being female and left-handed over the probability of being left-handed. So this is a little bit different.